K-fold cross-validation is in between cross-validation and LOCV. So cross-validation, we simply split our data into two different parts. One is for training, one is for test. And LOCV will run n different simulation, training and test process with single data point for test. K-fold cross-validation, simply split your entire data set into k different parts, 1 to up to k, and use the first data part as test and training your model with all remaining k-1 part. Okay, so this looks like LOCV, but we use a data subset or data block instead of just single data point. Okay, so like LOCV, we repeat this process k different time, and at the second page, we use the second data block or data subset for your test and all the remaining k-1 for your training, and we repeat this process k different times, and then average out each test error to estimate the real test error your training algorithm. Okay, so everything's same with LOCV, except we use some subset of data point to build a test data point. Okay, with cross-validation with k-fold strategy, estimate the cross-validation error using this simple empirical average. But if you have some biased block, if your data split has some huge subset or very tiny subset and the size of each subset are not the same, you can use some weighted average according to the size of subset, and you can compute this MSCI or error I if you want to use some different error metric. Right. Of course, there is some trade-off for the size k. How many data blocks we need to get very nice cross-validation performance to obtain very accurate estimation on your test error. How to choose the value k, that is the design policy for k-fold cross-validation, and that is not easy question. So as you increase the k, the pro is get more accurate estimation. Well, of course, there is cons as well. Training time will increase because you have to train k different times, right? So there is a pros and cons, and so usually we choose k equal to 5 or 10. That is common policy for k-fold cross-validation scheme. Well, I don't know which one is the best. It really depends on class of your algorithm you want to compare. It also depends on your data point.